We're going to be talking about the NX breach. So NX was a very popular package on NPM. It was compromised and malware was installed. This happens quite a lot with projects, but this one is particularly bad. I brought on two guests to explain why we're going to be feeling the reaches of this for a very long time. So to start with, let's bring on Charlie Ericson, malware researcher, to explain exactly what happened in this case.
NX is a package that is an AI-first build platform. Is kind of how they describe themselves. They call themselves smart repos, fast builds. Mm-hmm. So I've never really used it before, but yeah, it's clearly very popular, right? AI is all the buzz these days. And that also is interesting to see in terms of how the attackers actually went about doing their attack, and the techniques they used actually was seemingly influenced by the target that they were able to compromise.
Let's get into it then. So the package was compromised. Let's start off with how does it seem the package was compromised? Same old story with the developer token, it feels like?
Yes. What they're saying in the advisory that they posted was that they believe that an NPM token was compromised, which had the published rights to the affected package.
Malware was injected into it.
Yes.
Talk us through what this malware did, how it was being used.
Yeah, so this one is actually quite interesting because initially when I saw the top of the file, I was like, wait, this must be a false positive, because what I saw at the top was a variable called prompt. And it had this prompt about going and basically enumerating sensitive files on the file system. And I was like, okay, well, maybe our classification engine kind of made a mistake here, right? It's believing it a little bit too literally, because it doesn't seem to, right? That's not a thing on its own. But then I look further down and I see code related to actually running LLM clients. And then I see something about publishing a repository on GitHub. I was like, how does this make any sense? It's with a hard-coded repository name and no credentials, right? It will actually try to fetch the credentials from the environment. And well, what it actually does, first it goes and collects some of the basic system information, right? It will try to get like your GitHub token, NPM token. It will get just basic system information. But then it has this prompt at the top that says, hey, go and iterate the file system to a level of 8 in depth and collect all sensitive files and put it into a temporary file for me. And what it will then do is, assuming you have a GitHub token configured, it's going to go and publish a repository with this specific name, and it's going to base64 encode the sort of all of the things it has taken twice and put that into the repository. This is a public repository.
Yeah.
And this is where it gets crazy, right? So it's worth noting here, right? The fact that somebody's using an LLM as a way of enumerating your system, right? That's pretty novel, right? We haven't seen that before, which makes sense given what NX is. Right. That's a tiny story now compared to the fact that these guys decided that they were just going to, instead of sending it to a remote server that they control, they just publish it on GitHub, all of the data.
So let's just go over it just to make sure. Package was compromised. They inject some malware, and basically what this malware does was, using an LLM, enumerates through all of your system files. So once you install this updated version of this package, it enumerates through all your system files on your machine, on your cloud server, for example, and finds secrets, in particular things like your GitHub tokens, but also like your .env files, and then it publishes all of that not to a command and control. Well, I guess GitHub is the command and control server at this point, but like it's just like publishing it into a public repository for the world to see.
Yeah, so I guess you could call it very open source command and control. Which, sure, let's call it that. Yeah, so there's a catch there with the LLM part, right? Even if that doesn't actually do anything, it still collects your environment variables, GitHub token, NPM token, right? It has specific logic for fetching those. So when I looked at GitHub and searched for repositories with this name, I saw like 1.4K. And a lot of those had NPM tokens. And of course, they had a GitHub token because they could publish that repository.
This here is crazy for so many reasons. I cannot wrap my head around why an attacker would do it this way and why they would put secrets in a public GitHub repository as opposed to a private C2 server. But they did. So what I wanted to do is I wanted to bring on someone to help explain why this is such a big deal, having these secrets in public space. And there's no better company to talk about secrets in public Git repositories than GitGuardian. GitGuardian does wide sales scanning on all public repositories. They found last year 22 million secrets. And we're lucky to have Guomadon, a security researcher at GitGuardian, to explain to us some of the impacts of why this is going to have a long-lasting effect. Guillaume, welcome to the show. Thanks so much for joining us.
Thank you. Thank you for having me.
So as we kind of just recapped, the secrets were put in a public GitHub repository. Why on earth do you think an attacker would do this? Is there any kind of logical reason behind it?
Okay, yeah, my answer will be, I will say a lucky guess, but first thing, I think it's simple. I mean, the guy did a nice piece of work, like stealing GitHub tokens and valid ones, because that's the way NX works. He needs valid GitHub token to be able to help developers to do their job. So for him, it was easy to use the GitHub token and actually upload some stuff to GitHub under the developer account. So simplicity. And also for him, it's also a good way to not be traced. So usually when you are trying to trace attackers, you're looking for IOCs, you are looking for IP addresses. So for him, it's better to push it on a GitHub public account or a public service than to actually push it on a private server. It doesn't need to buy a specific server trying to hide it and so on. So I will say simplicity and deniability. And so that for the exfiltration, it's also in the first place, we don't really know how the NPM package was actually backdoored in the first place. For the attacker, it looked like a perfect operation. We don't know much about him.
In total, how many repositories did you actually find from this? How many repositories that were exposing secrets did you actually kind of uncover?
I didn't check just before the recording, but when I published the blog post yesterday, there were more and more repositories being published. So when we did the extraction, we found 1,346 repositories, a bit less with actual content, close to only 1,000. But yesterday night, there were more and more, not that much, but if you do the query, the Singularity repository query on GitHub, you will find a few, or at least yesterday it was a few. And inside, it was also possible to find secrets, and some of them were valid. So for me, I don't know why, but it seems that some systems are still using the backdoor package and are still publishing secrets to GitHub. So it's likely that GitHub will react really fast and try to block all of these patterns. Singularity repositories. The pattern is quite simple. The name, it's Singularity with a one instead of I, and then dash with a number. And then inside the repository, you have only one commit with always the same name, and then the file with which is result.base64. In the content was one really fun story. So every time you do this kind of experiment, getting data publicly in the wild, you will write your own code to actually get the commits, do the base64 de-encoding. And at some point, my code broke. So I didn't know why. I tried to debug that. And what I got back was not indeed JSON. It was a YouTube link. And the YouTube link, if you click on it, you would get a Rickroll video. It was really fun. So someone actually pushed some content for like researchers like us at GitGuardian to actually break their stuff or make fun of us. But it was fun. So two people actually uploaded the link to the Rickroll video.
So that's a pretty good indication that thousands of applications, of developers, of organizations have had their secrets just exposed in public. And why is it so much worse having these secrets exposed in public than it is for like the attackers to get them?
I will say worse than not. So it's worse because anyone can grab the secret. You, me, GitGuardian, anyone, governments, other bad actors. And I will bet that other bad actors did actually got the secrets. because what we found that the exposure ranges from like single developers trying to play with NX to big companies. And also we found internal, again, Artifactory instances who have big name there. So it seems that it's not only the guy that did the supply chain attack in the first place that will access the secrets. And yeah, publishing this stuff publicly is worse, but it's worse as a pure defensive story and side of the story, because it means that you don't know actually who we get your secret. But if you are trying to, on the other hand, to understand the full story, trying to as a developer trying to understand if you were targeted, I mean, in that case, because the repository was created under your GitHub account. To actually know, it's really easy for me to check if I was targeted. I can just go on GitHub, type github.com/my nickname, Gadu/singularity repository-0-1, and so on. So for me, it's easy to check. So this is this, what do you say in English, double-sided coins. There is the public exposure, which is really bad, and that will make the blast radius bigger than for the single attacker. But on the other side of the coin, you have also an opportunity for people and developers to actually check and quickly check if they were targeted. And that's really good for what we call a blue team, especially in big companies, to be able to check if their developer were targeted by this attack. And that's part of what we do at GitGuardian. We're able to map usernames to companies, and that's a product that we sell. And for us, it's really interesting because we can actually warn customers that their developer were targeted. In the case of secret, there is also, in secret and security, there is also people trying to avoid the reality. They will say, yeah, maybe the attack did not work, or maybe the attacker did not actually look at my secret, or maybe the upload did not work. So in that case, we know. So the data was uploaded and contains secrets. So it's not possible to deny and say, I don't care, I will not act, I will not do revoke. So you need to revoke because you know.
Let's get into some of the juicier stuff now. What type of secrets did you actually kind of uncover in these public repositories? What were the main secrets, and what were kind of some of the outliers that you saw? Did you find anything really terrifying?
So I will call them the usual suspect. Usual suspect in the sense that's what I do at GitGuardian, so security research. I come from a background of doing offensive security for pen testing company, for French governments. And what I call usual suspect is that secrets, valid secrets that can be, let's say, weaponized. Or VCS, in the case of this dataset, that's only in many GitHub. I think I found few GitLab tokens. Cloud, we have AWS, Digital Ocean. So it means that it's likely that an attacker will be able to pivot into some cloud infrastructure, which is unfortunate. We have databases. Some of them are related to production because you can see the prod keyword in the host name. And something, again, big usual suspect, artifact and artifactory. We have valid artifactory tokens in the dataset that are valid for really, really big companies. So what... it's not a big surprise because that's the token that developers will use on a daily basis to do their job, to push code, to actually modify the infrastructure, to put data in a database, and finally to upload or download artifacts. So nothing is really standing out. But I get that for developer, it means that they will need to take a big care of checking what is loaded in their environment variable, or what was loaded, or targeted, and try to remediate. And to do so in the next few hours or minutes, we'll publish the secret that we found in something that we call As My Secret Leak, which is a database of secrets that we found, that's leak secrets, that will help people to check if they were actually targeted. There is a command line tool, which is called GGShield, that you can use to actually check if the secrets are in our database. You don't need to, and you will not actually send the secret in clear. They are protected with the hash, and you send the hash, and we say, okay, we actually seen this leak or not.
When we first started looking into this, we looked on GitHub for repositories named Singularity Repositories, spelled with a 1, and we found thousands. Shortly after that, they had all been wiped. And then throughout the day, more ones kept coming up. They would keep getting deleted. more ones would come up, they'd keep being deleted, etc., etc. What was actually going on here? Who was deleting these repositories?
Yeah. I don't know if GitHub is doing anything about it. I mean, I know I don't have any precise information, so it's just, again, guessing. I've seen two different things going on. First one, some repositories are deleted. So if you go and try to enter them, you'll go get a 404 page. So for me, it's likely that the developers that were actually targeted by the attack decided to just delete the repositories. So that's my first guess. And the other one, I think that GitHub is doing something about it, because from time to time, when you try to access a repository, you will see that it's deactivated. And in that case, you don't get the 404 message. You have a former and a proper message from GitHub stating that the repository was deactivated. And I think that's a good move from GitHub if they are doing that, because it allows developers to actually check if someone created a repository named Singularity repository under their name, and then trying to get the secrets in the blob, in the base64 blob, and then trying to remediate.
Okay, so GitHub or someone was deleting these repositories. Does this actually help? Does this resolve the issue? Are the secrets now gone?
Basically, what we see at GitGuardian since day one, it's deleting leak is not helping at all. I mean, it helps not the leak to be seen, but the secrets are still likely available to people that donated them in the first place, and also they're still valid. So the first thing you need to do when you actually leak, or actually in that case you didn't leak anything, but someone took your secret, put them on GitHub, you need to have a look and do some kind of inventory and revoke and rotate everything. That's the only way to actually protect yourself from what happened yesterday. Identify the leaks and rotate the secrets.
I want to put you in the position of a black hat hacker now, but I want to ask you the question, what would you do to kind of take advantage of this? How would you find and use these secrets?
Going back to the usual suspects category, for the VCS one, the first thing will be to actually check what can be accessed and download more code. And what we know at GitGuardian, if you have more code, you have more secrets, hard-coded secrets, because that's the way people do the hard-coded secrets. And then using these other secrets, you can pivot. For the cloud, you can spawn instances in the first place and trying to... So some people will do crypto mining, but it doesn't get you much money, but some attackers do that, or they can just destroy your cloud infrastructure. That would be the nightmare scenario. For cloud. And for DB databases, they can just get your data and try to actually leak, ask you for money. Obviously, they can also go for the ransomware stuff, trying to encrypt your data and ask you money to get you back. And for the artifacts, it could be the same thing that started the NX attack. It could be a supply chain attack, taking your artifact, putting bad code in there, and then trying to pivot and do lateral movement into your architecture.
Well, Guillaume, it's been an absolute pleasure to have you on the show. I hope to have you back again, hopefully in less crazy situations, but really, I really enjoyed it. And thank you so much for coming on and sharing your knowledge today.
Thanks for your time.
If you enjoyed that clip, you would love the full show. The Secure Disclosure is a show that comes out every single Thursday, and we bring together key guests and leaders. Subscribe to the YouTube channel or find us wherever you get your podcast fix to stay tuned.